What? Oh no.
That is a good point. Now remember, I will tell you a hint. I hope everybody has a pencil and a piece of paper, because a lot of things on these slides will be on the Kahoot quiz at the end of class. So if you want to be the Kahoot winner and knock Gavin off his throne there, first place throne.
Gavin, I have a mortal, my mortal nemesis, Gavin.
Quick question. Does anyone know what a black dwarf is?
Yes.
Yeah,
You do?
the white dwarf
Yes, I
but
do.
better.
Yeah, no.
I have a picture of one.
Yeah, so for anyone who doesn't know what this is basically a theoretical star that could possibly exist after a white dwarf star cools down, but I mean, none
is
of them
correct.
even exist yet.
Yeah,
And,
you're
and I
correct,
heard
yeah.
one time that it should take about pretty much the end of everything, not like a heat death, but
Yeah.
all life.
That's a long time.
That's exactly right.
Yeah.
So you can teach the class. I love it.
Oh wow, Genius Science Academy. Nice.
That's right.
Whoa.
Because all y'all are geniuses.
That's a big reputation right there.
That's
If
right.
this is for
Everybody's
geniuses,
gotta
I should
live up
leave.
to this. Oh, well, everyone's going to be a theoretical physicist, right?
Well, about that.
Maybe when I grow up.
All right. Is everybody excited about black holes? We can actually begin if we're ready.
Yay.
All right. So let's talk about black holes. And well, along with some time travel. First, I want to kind of recap last time. So before we get to a black hole, a star has to kind of die. So does anybody know how a star dies?
It explodes.
Okay. Becomes a supernova.
It
runs out of
compresses into
fuel.
itself.
It runs out of fuel.
That's right. So remember our nuclear fusion from last time? Well, when it runs out of all those hydrogen atoms, right, to turn into helium, the fusion runs out. And guess what takes over?
The gravity.
The gravity. Dun, dun, dun. I need ominous music on this.
Hold on, I got
Yeah.
it. I got this.
So yeah, who's my sound guy in this?
Me.
So gravity. So gravity starts now compressing everything smaller and smaller and smaller. All right. So that's how a star we'll say quote unquote die. It doesn't really die, but it runs out of fuel, right? Okay, so here are some examples of stars. So which one would be our sun? The low mass star or the high mass star?
The low mass.
Low mass
Low
star.
mass.
Low mass star, right. So our sequence is red giant, right? So it's gonna actually grow 100 times the size, right? That's when it starts to, we won't really be alive to see it become a white dwarf, right? Because it's gonna engulf Mercury, Venus, and come very
yeah.
close to us.
Yeah, I mean, and if it did get like that close to Earth, we'd literally, the
It's
whole
game
entire
over.
planet would burn away, basically.
That's right. We a lot of us would be incinerated, right? Which is
Everyone would.
why we need to go to Mars, right?
Somehow.
We're moving to another planet at some point.
Yeah, I mean, we could go to, I believe it's one of Neptune's moons. I know there's a
Huh.
few moons from other planets in our solar system
That's
that
correct.
But wait,
could support
Europa.
life.
if the sun
Europa.
goes bigger, then Mars will be
Exactly.
one of the first to be destroyed.
Yeah, and I
That's-
think
yeah.
Deimos too. Deimos.
Yeah, I think Europa, we're sending I was going to talk about that next time. We're sending a probe over there, a little rover, because they're supposed to have big oceans.
Ooh.
So-
Sounds like you've already got some real estate picked out over there.
That's right.
And fun fact, So I heard this on it's called
National Geographic.
Kazakh in a nutshell.
Oh,
is that,
yeah,
oh
it's
yeah,
really
I know
hard
the
to
one.
That thing is
pronunciate.
terrifying. All right.
It's
That
terrifying.
gave-
Bum, bum, bum.
Yes, that gives me genuine fears. But so they basically talked about if there was going to be a planet with life, it would most likely be underwater, under ice, with geothermal heat keeping them alive, and they will most likely
Europa.
never get out of the ice.
Yep.
Because it'll
That's
too-
exactly what Europa is. Very good. Yeah, and we're sending there's a mission to go there actually and discover life in the oceans under the ice there. That's awesome. We'll talk about that next time for sure. Okay, so let's focus on dying.
Oh,
Wow, this is a depressing class.
I know.
This took a
This just
dark
took a
turn.
big turn.
well, in that case, you can get my mom for that.
It's a little hard.
Oh.
She
Okay,
gotta
so
keep-
our sun will then eject, right, all of this, the sun's core, and just explode. And then the center core will be composed of a white dwarf. So we got carbon, oxygen, neon, magnesium. This is where we're starting to put all those protons together to form bigger and bigger elements. Now, what we're going to talk about today is high mass stars. Okay, these are 150 solar masses, like the 150 times bigger the size of our sun. Okay, they will then turn into giant super suns, right? And then they also explode into supernova, right? Now, some of them will turn into neutron stars, which is exactly what you think it is. It's nothing but neutrons, right? In a small, dense clump, probably the size of like a city. So it's pretty small and a very, very dense thing. And then some will turn into black holes.
Yes.
Okay. So we're going to talk about the black hole part today. Okay. And the cool things that happen when you actually can turn a star into a black hole. We're going to look at a little video on kind of the progression of that, but mainly on how the supernova is going to turn stars into the elements we see today. Can everybody hear it?
After Threshold 2, the universe had lots of stars, but most of space was still cold, dark, and mostly empty. The universe consisted almost entirely of two types of atomic matter, hydrogen and helium. These were both light gases, and one of them was totally inert. Like a painter with just two colours, one of which won't mix, it was impossible to make anything very interesting. The universe needed more colours, more chemical elements, and that was the work of Threshold 3. Making new elements meant fusing more protons and neutrons together. To do that, you needed very high temperatures, which could only be found inside massive stars that were aging or dying. Only they have the right Goldilocks conditions for Threshold 3. Why? Well, large stars have so much mass that they can create enormous pressures and temperatures. Those temperatures get cranked even higher when large stars run out of hydrogen. When that happens, fusion stops at the center and the star collapses like a burst balloon. If the star's big enough, the collapse is huge, creating such high temperatures that helium nuclei can fuse into nuclei of carbon. When the star's used up its helium, it collapses again, and the cycle starts over. The star heats up and starts to fuse carbon to form oxygen. It collapses again, then does the same to create other elements like silicon, nitrogen, and eventually iron. If it's a really, really big star, it'll finally die in what's called a supernova. That's an explosion so hot and so energetic that, for a while, it'll shine like an entire galaxy. and it'll produce enough heat to form all the other elements of the periodic table. Then the supernova scatters these new elements into space, and voila, we have a universe with lots of different elements. Threshold 3 was crossed for the first time when the first large star died. And it's still being crossed today, as billions upon billions of large stars die, scattering the raw materials needed to build wondrous new forms of complexity.
All right. So that's how we make most things in the universe. Any questions? Is everyone still there?
I mean, yeah.
Yes.
Okay, making sure you didn't fall asleep.
No questions.
Is everybody familiar with the concept of constant energy in the universe? The law of conservation of energy is what it's more commonly known
Yep.
as.
Yeah, a little.
That video kind of hit on that, right? Where,
No matter is destroyed. It's just constantly shifted to different forms.
It changes form, right? The total amount of energy in the universe does not change, but it changes forms.
Yep.
From mass to energy to different types of energy, etc. So that last video was kind of a hint toward that.
All right, so now what we want to do is destroy all of those things we just created.
No.
All right.
That
so
sounds kind
how-
of evil.
This is a dark lesson today. Okay, so how can we make a black hole? What are some suggestions?
Kill a star.
Okay.
You
And then
can
what?
smush something. You could use something to smush something down to very small size.
That's right. That small
You can
point
throw
is called.
two neutron stars at each other.
Okay, that's pretty cool. I like that idea.
Um,
And I think that's actually how super massive black holes are formed, when more and more mass gathers and gathers and gathers. So
yeah,
this-
like that.
Well, if you had like two galaxies full of neutron stars crash together,
that happens, right? That can
Yeah,
happen. in space.
big black hole.
And that's
Yeah.
right. That'd be a supermassive black hole.
I mean,
Right,
kind of
so-
like the.
So if you have all that mass and you're concentrating it to a teeny tiny point, right? That's called the what?
Singularity.
Singularity. That's right. All right. So here's a sort of a depiction of what a black hole would look like, right? So we have, this is here, see if I can actually do a thing here. Here we go. So right around here, this would be all of the stars and dust and mass and things that it's kind of gobbling up. This is called the accretion disk, okay? And this is where everything's spinning around super fast. The star spin around the black hole before it actually goes into the black hole. And then when it's sucked into the black hole, there's a point here called the event horizon, okay? There's actually a movie called The Event Horizon.
I wouldn't
Is it
recommend
about
watching.
someone going into the black hole?
That's right.
Yes, but it's
Yeah.
not for it's for adults. We'll put it that way.
Actually, not so fun fact about black holes. If
Uh-oh.
you go in there, there's no telling what will happen to you. But on the outside, I believe I heard that you kind of just stay there forever, and I believe that you get smaller and more twisted or something. But
Yeah,
they can
so that,
basically see you.
So,
yeah, so
like
technically it's called spaghettification. You
spaghetti.
become like spaghetti.
Spaghettification.
Ow.
A highly
So-
technical term.
That's a technical term.
So, in a way, this is the void. Like, if you entered it, in a way, it would be the void for you.
Or it's where everything is.
Well, I think we would
Everything is
instantly
where everything
die
dies.
because there would be no oxygen or anything like that to support our bodies. So I think also
Yeah,
would
that's
be
kind of the bad part,
crushed,
right?
all that, you know.
So if
I'm
you
pretty
lost
sure you
your
wanna
sandwich
live to
down
see
a
what a
black
black
hole,
hole
it's never
is like.
coming out.
Yeah.
That's right. Once you pass the event horizon, that's the point of no return. You cannot come back out. Okay. All right. So
can you-
here's a really cool picture, I thought, of a side view of the black hole. So this top part here would be the accretion disk. And what you're actually looking at is you're looking at an object from the front and the back of the object. Does everybody get that?
Same time.
At the
What?
exact same time. So because black holes can warp space-time, you can actually see this. You can see the front of it and the back of it at the exact same time. Meaning if you were a person standing on the accretion disk, you could see the back of your head.
Whoa.
That
Yo, that's creepy.
is really creepy.
If I could just put something in here. There's this
Yeah.
really cool YouTuber and he's a master Minecraft builder. Either way,
Mhm.
he set up to build a scale model of the solar system
Uh-huh.
and with surrounding celestial objects.
Mhm.
And he used math and stuff to try to make his own black hole using
That's
different
pretty
lighting
cool.
and things like that. It is
Yeah.
a really crazy video. He's like super good at it and it actually looks super real.
Yeah, so actually on Khan Academy, if you do that, and they have a whole section on black holes, they actually help you make computer simulations of if you wanted to create your own accretion disk and black hole.
Wow.
So you can actually learn to code and make the accretion disk of the black hole.
Yeah.
That's pretty cool. I love it. Computers are great. All right, so let's see. The question is, could you escape a black hole?
No.
God, no,
No.
not even
No.
not even
Well,
like-
not past-
Actually, you can
can't
escape
past the
You
event
can
horizon.
escape.
Man,
Um,
a lot of mixed opinions on this one.
Wait,
you
what if
can
you
escape
made a
out of the
black
first
hole?
escape it,
part
there's
that's
no
in it,
question.
but you can't
If you
leave.
What if you
escape-
made a
You
black
can't
hole
escape
inside
the
of a
event
black hole?
horizon. After
All
you
the
fuck
all the
that,
all the
right?
yeses, raise your hand.
Yes,
What?
please. You can escape a black
No.
hole.
Yes,
No, you
person.
can't.
No.
No, if
No,
you if you
depending-
not.
if you
You
get
can
in
escape
that
a black hole depending on where you are in the black hole.
if
That's
you get
correct.
if you get in the event horizon, there's like almost no getting out. I mean,
But if you're in,
get out.
Yeah.
I mean,
so I
actually,
think
I believe I have heard of this. It's you can get in, but I believe you have to be pretty deep, and it's I forgot most stuff about it, but I mean,
okay. So let's
Black
talk
holes
about
are black holes are like Hotel California. You can check in, but you'll never check out.
Whoa.
Wow.
I don't know if
Never understood that song.
Ask your parents about that.
Oh yeah, and I heard that like if you were to escape, you'd have to be going faster than the speed of light, which already, if you were, you'd be breaking.
The theory of relativity.
I
speed
mean,
limit.
yeah, you literally can't go faster than that, and if you do it, I don't know. I heard it somewhere. I just know a lot of random stuff.
You'll be
You're
breaking the law of physics.
I'm
That
just
it would
wondering-
kind of like break the universe.
Okay, so at some point, so that's absolutely correct. At some point, when you fall down, you're going to meet the event horizon. Okay. This is the point where to escape, you'd have to be before the event horizon and you'd have to be traveling faster than the speed of light.
Okay, so it's impossible.
So theoretically, it is impossible.
So, well,
Once you
what
cross
if
the
you
threshold.
what if you, that's right. What if you haven't crossed the event horizon?
then you can.
Yes.
Okay. There's 3 parts of it. You can escape the first part, but you can't escape
You
the
can
second.
space
and
swim out of
third.
it.
Okay, so there's an actual mathematical equation. Okay.
What?
Yes. All right. So this is, and I hope you guys are writing this down. This is going to be on your test.
Oh,
Am I the only one that's writing it down?
yeah, I
All
think
right,
so. I
so-
haven't been writing anything.
So a good example,
I haven't either.
So
I'm
here's
just
the-
relying on luck.
I love it. The anatomy of a black hole. All right. So you have the singularity in the center. And you need what's called an escape velocity. The speed at which you need in order to escape this object, all right? And it needs to be greater than the speed of light. at the event horizon. So the question is, can you escape a black hole if you just go by and like look at it, right? You don't go in, but how close can you be? And they call that the Schwarzschild radius. How close can you
The
actually come
Schwarzschild?
to a black hole to escape it if you're traveling at the speed of light? So here is a really good example. Who knows the escape velocity to get off of our planet Earth?
It was 11 point something kilometers per second.
1.2.
Mhm.
I don't know kilometers.
SI units, man.
I know,
Um,
I'm
seven
in
it's-
the
miles.
miles per hour.
It's about
Take a
7
mile
miles a
divided
second.
by 60, you have a kilometer.
Mhm.
It's up there as well. 7
So-
miles a second.
Oh, God.
Mr. Mike, you want to explain how to get off the Earth?
Well, what are we trying to overcome? Why do we have to escape Earth?
Gravity.
Gravity. That's right.
Because we want to know more.
Well, that's why, right? It's how is another mechanism. So it was proven a long, long time ago that anything with mass exerts a gravitational force on everything else. The more massive the object, the more gravitational force it exerts. It literally pulls things toward it. So we're all standing on the Earth because the Earth's core, its average radial core, the distance to the center of the Earth, and the mass of the Earth exerts a force called gravity on us, right? So to launch rockets, something we know a lot about these days that we didn't before, but to launch rockets, we had to understand what this critical velocity or escape velocity was. And through some studying and physics, we were able to come up with a formula that tells us exactly what, for using a universal gravitational constant, right, a number that does not change no matter where you are in the universe, the mass of an object and its radius, which makes sense, right? Because we're on the edge of the Earth and we're trying to get out of it, right? So your distance from the center of the massive object plays a part. You can calculate how fast you need to be moving to overcome the force of gravity that object exerts on you. And it's
And
a
it
pretty
happens
simple
to be-
formula, right?
Yep.
Yeah.
And it happens to be 11.2 kilometers a second or 7 miles a second. So how can we relate 7 miles a second? How fast would, that's traveling pretty fast.
Fast.
Yeah.
Yeah, so for those in Houston, which we're familiar with as well, from the Woodlands to downtown Houston is about 40 miles. So could you imagine going from your house in North Houston, traveling 40 miles to downtown in under 5 seconds?
Wow.
No.
No, I
Wow.
don't think so.
It's pretty fast. Yeah, be pretty
It would
fast.
be fun.
It probably
Yeah.
take our
Well,
hair off though.
every astronaut that's ever left the Earth in a rocket has at least traveled that fast or faster.
Wow.
Yep. So here's the question. So that's how we escape Earth. Now that's with a spherical object. Okay. Now we want to get out of a void, a spherical void, right? The event horizon. So the radius of that will comprise of something a bit different, right? The radius will now comprise of this. Do you see, everybody sees this C squared here? So now we're introducing what? Who remembers what C equals?
Speed of light.
It's the speed of light.
That's right.
I answered that at the speed of light.
So the answer to this question, could you escape a black hole, is the Schwarzschild radius. So that is involving the speed of light, and it's the
So-
distance you have to be from the black hole to escape if you're traveling at the speed of light.
Speed of light squared.
Well, it's,
So that's like if we invented a spaceship that could travel at the speed of light, right? Mr. Mike, any other input?
no, I was gonna say that this Schwarzschild radius, it's a unit of measurement for the distance you have to be from the center of a black hole. And you'll see it's not, if you're one radius away, it doesn't mean you can escape. You have to be a certain number of radii away from the center of a black hole based on its mass, which determines its gravitational pull, to even stand a chance of escaping. And you have to be traveling the speed of light.
So remind me again, from here to here, from the singularity to there, how fast do you need to be? Well, it has to be above
Yeah.
the speed of light,
You
but from
have to
here to here.
you have to be at least 3 Schwarzschild radii away from the center of the black hole to even stand a chance, and traveling the speed of light. So you got some stuff working against you.
All right, any questions?
I don't think so.
Okay. So the answer is yes and no.
You just have to go really fast. That's the answer.
Really fast is a, yep.
Yes.
We could run that fast. We could be here and there under 1 second.
Mm.
Under a second.
Well,
I want to run
I
that
think we-
fast. I want
I
to be
think
the
we'll
fastest
see that in
dwarf
a
the
little bit.
world.
We did some creative stuff last night to kind of put into relation how fast the speed of light is versus how fast things tend to travel in orbit around the Earth, just to kind of show you how long it would take to keep up with the speed of light, right? Because we measure distance in space in light years, or we tend to.
That's right. We can actually talk about that if we want, let's say.
Like weeks.
Well, I'll get to that in a second.
Weeks is an understatement. Aim higher.
Like hours? Like minutes?
Well, so I didn't, Mr. I don't
Here,
know
let's
if we
see if
want
I
to
can
go
find it.
through.
Yeah,
Like-
let me see if I can find it. There it
So
is.
we know that we are not the center of our universe, despite what we may think of ourselves sometimes.
Oh,
We
Ha
are
ha ha.
we are actually encircling
funny.
as part of the Milky Way galaxy. We are encircling the center, right? We're one of hundreds of billions of solar systems in the Milky Way galaxy. It's a spiral galaxy, which means it has a center about which the rest of us are going around on a kind of like a merry-go-round. We've been observing the sky since humans could look up. And more recently, over the last several hundred years, we've been taking pictures of the sky to try to figure out what's going on. And we notice that things are moving relative to each other, but have patterns. And those patterns have allowed us to measure and take quantitative assessments of what's going on. And we've actually been able to pinpoint where the center of the Milky Way galaxy is.
Yep, we
Isn't
call
that
that the
black hole? Is it possible for two solar systems to cross over?
Yep.
Absolutely.
Yes, that is absolutely possible.
Yeah,
That
we
is-
have a picture of that.
It tends to be when worlds collide, as they say, because each star has its own gravitational pull, and if two of those collide, bad things are going to happen to any life that exists on those planets
Right.
and those solar systems. But
So
You
who can
So-
tell me from this picture how far we are away from the galactic center?
Oh god, billions of light years
28,000
away.
light years.
100 million kilometers.
It's right here. I'm circling it. How many light years?
28,000
I'm gonna
light
guess
years.
like
28,400.
20
light
billion
years.
light. 20
Okay.
billion.
108,000
I'm
Light years
looking at the
wide.
screen and
I
she's
am the
told us
first-
to look
I
at
am
the
first
screen.
person in this.
let's call on somebody.
I answered it 3 times and everybody was
Yes.
talking over me.
There were
Yes.
multiple correct answers. That's right. So
Yes. Okay,
28,400 light years.
So here is my question then. How many kilometers is just 1 light year?
10 trillion.
10 trillion in just one of them.
Really? I was taught it
Right.
was 6 trillion at school.
It's 10 trillion kilometers in 1 light year.
Wait,
So you
Mom,
have
can you-
to, yeah,
can you stay on this side for a little bit? I gotta write down all the zeros on here.
oh yes, yeah.
Thank you.
Oh, those
Scientific
zeros.
notation's a beautiful thing.
Yeah, just count the zeros and times 10 to the whatever, however many zeros you have there.
I already wrote all the
Um,
zeros though.
Just do
Okay,
an exponent.
so you would have to, yes, this will be on your test later, if anyone's wondering. All right, you would have to multiply 28,400 light years by 10 trillion to only get the number of kilometers light can travel, the speed of light. That's not us. Do we travel at the speed of light?
God, no. We travel way under.
So what would you have to do?
Be the Flash.
Does this number get larger
think he
or
can travel that
smaller
fast.
for us?
How
Small,
many years do you think it would take us to travel that far?
a lot,
Couple
1,000
million.
years?
a
Billions.
good amount.
Millions.
It's almost a billion.
Probably longer than the space shuttle would last.
Longer
Yeah,
than
so-
any of us would
yes.
last.
That's right. So if we took our shuttle to the center, it would be almost a billion years to get to the center of just the Milky Way galaxy. We haven't even left our galaxy.
Yeah, and question, is it true that we haven't gotten like an actual picture of our galaxy and we just use pictures of others?
No, we do have pictures of our galaxy. And I'll
Oh.
actually show them here in a second.
Okay.
All
Yeah.
right. So do you want to say anything about the force of gravity before we move on?
No, I made
Okay.
sure we included this in the lesson because I remember a distinct class in my high school physics class where we reviewed this exact formula. It's been proven true for any two objects in the universe. You can calculate the gravitational force of attraction between them based on the mass of the objects, the distance between their centers, and using the universal gravitational constant. So to me, that's pretty neat, right?
Yes. Very. It went silent for
Consequently,
some reason,
if-
I'm not sure why.
Consequently, if you use that same formula with your mass, the mass of the Earth and its radius, you can calculate your weight.
That's true. Yeah,
So if you don't have a scale, then you could just do that.
that's
Well,
right.
that's the verification part, right? We calculate and then we verify with physical measurement. So you could use the scale to check your calcs.
Nice.
All right, here's my next question for you guys. Can you time travel through a black hole?
No.
Wait.
I
No,
mean-
because you get spaghettified. I don't think so.
I heard
mean,
that if you're
it's-
Yes.
I mean, yes, it is
Theoretically
technically
possible.
possible. I mean, but like, so I've heard that when you're in space for long enough, that like you don't age as fast, I guess, as other people on Earth. So I heard,
Meaning you would go slower in time than other people.
yeah, and I also heard that we can't go back and we can only go forward.
Actually, I do think that you do go forward in time because if you have like a spaceship back there that has a clock on it, the clock slows down if you look at it.
I have. That's
I think
exactly.
you're
How
saying
do
the
you
same.
know that? How do you
I
know
think you're
that?
saying the same thing.
Because I watched a video on it.
Oh, I thought
Okay,
you meant
I,
an actual black hole.
Here,
I
let's
heard-
see. So this is a YouTuber. Let's see what he says about time traveling through a black hole, because I think
I
you
am
guys
right.
are gonna find your answers are pretty much the same. Let's see.
Space. What's in space? Black hole. Black holes have been a topic of discussion since Einstein first predicted their existence in 1916, and even in 2019 when his first selfie without makeup was released, along with internet-wide disappointment. While I was binging some science fiction TV, I noticed black holes are always used to explain time travel. But what do black holes have anything to do with time travel? Well, to understand that, we have to look at Einstein's theory of relativity. This basically states that the faster you move through space, the slower you move through time. 10 years later, he then updated his theory to include gravity. So the stronger gravitational field acting on you, the slower you move through time. Not convinced? In 1959, cobalt clocks were placed on top of the Harvard University building. Another clock was placed on the ground floor. Based on this theory, the clock at the bottom should move slower since it is closer to the center of gravity of the Earth, which is exactly what happened. This is known as time dilation. Therefore, if you can withstand a great amount of gravity for a period of time, it is technically possible to travel into the future. Well, think of it more like fast forwarding your life, like in the movie Interstellar. Einstein believed that space and time are one and the same, and hence created the mathematical model of space-time, which is a fabric that combines the 3 dimension of space with the 4th dimension of time. The fabric of space-time can be warped through the gravitational field of objects. The stronger the field, the more warped it is. So how does this link to black holes? Well, black holes are collapsed stars that have such a strong gravitational field, not even light can escape it. Wait a minute, no light coming out, so it's black. Oh, black hole, I get it. Yeah, it took you a while. Because black holes are the Satan spawn of gravity incarnate, weird timey-wimey stuff happens inside a black hole. This is a black hole structure, and this is what you call an event horizon, known as the point of no return because nothing inside it can be observed from the outside. Now this is the cool part. Through manipulating some equations, we can figure out that inside the event horizon, the coordinates of space and time are swapped. Whoa, cool. But what does that mean? Well, you see, in space we are free to move in any direction, but only forward in time. In the event horizon, however, they are swapped, so we can freely move through time, but not space. Theoretically, this makes time travel possible, and is what most science fiction titles exploit to explain their time travel shenanigans. However, they overlook the fact that you will most definitely die, since you can now only move forward in space, and no matter what direction you try moving, you only die faster. Not very nice. However, some titles goes above and beyond to try and explain this plot whole, using something called a Kerr black hole, which is a spinning, non-charged black hole. The special thing about this black hole is that there are 2 event horizons, meaning that space and time will get swapped twice. So in the first event horizon, same stuff, travel through time, inevitable death. But when you get to the second event horizon, we can now control our position in space again. Therefore, after we've already time traveled, it is possible to escape being crushed in the singularity of this black hole. Voila, time travel accomplished. Keep in mind the other laws of physics, such as laws of causality, are a bit unclear when it comes to backwards time travel. So, is time travel possible? Who knows? But it's still fun to think about.
Okay, so what do you think? Can we time travel?
I
Yeah.
think
Yeah.
like by not that much, but we can.
I mean, yes. So basically,
Theoretically.
yes.
Not
so
like
we-
hundreds of years, but
so we can, travel into the future. You would say, but we can't travel back because you would only be able to travel back, from what I heard, to the point where this warp or portal, I guess, whatever you want to call it, was created. But you can go forward because that portal should always be there unless something happens to it. Like, I don't know, like it's somehow destroyed, I guess, like a fire or something.
I love it. So there's
Good.
3 things that are pretty key for that, is that space and time, when you talk about them, we can just put them together. Time and space are the same thing. We call it space-time, right? And you can sort of warp it or maybe curve it. So here's at the top of your picture, there is a little curvature of space-time, right? Light always follows the shortest path. And because we've curved its path, time will be slower on the part that's closest to the mass, that's curving space-time.
Everybody got that?
Thoughts? I know, it's a little confusing.
This gets heavy quick.
I'm scribbling.
That's all I hear. My pencil.
Does everybody get it? Do we need to explain Einstein's theory of relativity?
All I wrote down was what I heard that I could comprehend. Light always follows the shortest path, and that I get.
Okay, so if the shortest path is, so you see the picture of our sun here?
Mm-hmm.
So the shortest path would not be to be on the outside of the bowl, right?
Would
It'd be to follow.
inside.
That's right. So you want to go. So that means if space and time are the same, time will be actually slower than on the outside. That's sort of what it was talking about, how you can actually, gravity affects how time moves, and so does actual speed will affect how time moves.
Hey,
Uh,
have you guys heard of the theory that if like aliens or something like that look at us from billions of light years away, they will see dinosaurs basically.
That's right, because it's time is relative to the observer.
Take that a step further, Eli. It takes, I think, is it minutes or hours for light from our own sun to hit the earth?
It takes
No,
8 minutes.
8
So
minutes.
Minutes. There you
so
go.
if the sun exploded, we wouldn't know for 8 minutes. But then again, if it exploded,
It'd probably
we'd
have
be
some
dead within
effects.
those 8
Yeah.
minutes.
We just
Right.
be dead and have no reason why. Until 8 minutes later.
Okay, so in theory, is time travel possible?
Yes.
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 Can you time travel right now?
No,
Not yet. Not with our technology.
well, not with our current technology, I guess.
I mean, yeah, like we know more about the surface
So-
of the moon than the bottom of the ocean.
Okay, but if gravity and both speed affects time, couldn't I just get on a rocket ship?
No,
No?
the rocket ship would
No.
be destroyed too.
That like astronauts that have gone to space and been on the space station, when they came back, their watches would be like 6 or 5 minutes behind.
That's right.
We just saw in that video where two clocks, one at the top of a very tall tower and one at the bottom, showed different times because of the gravitational effects on the two.
Yeah. So time travel, we time travel currently.
Miss
We
Tara,
just- Yes,
is it possible to time travel by going like fast enough?
yes. Here, so here's an example. Now, before, oh, somebody's dog's barking. You might want to mute your thing.
Those dogs.
There's some loud dogs.
So in this video, this is a astrophysicist or theoretical physicist as well. And a clock, when you look at your watch, we have the second hand ticking, right? And every 60 seconds, then the minute hand moves. Well, another type of clock is if you had two mirrors opposite each other and you put a laser between them and had the laser bounce from the top mirror to the bottom mirror, tick, 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 and you could count that. And this could be a type of clock, okay? And he's gonna demonstrate how to time travel. Are you all ready?
Yeah.
Uh-oh.
Okay, we're gonna learn how to time travel.
Gotta write this down.
Tick. Tick. So that's like the pendulum, the beam of light bouncing between the mirrors, and you could use that actually to build a very accurate clock. Then Einstein imagined what that clock would look like if it were moving relative to us. So what I'm going to have happen is Jim is going to be moved
Jim.
along the stage. Keep moving the clock. And then we can dim the lights and we can see what that looks like from our perspective. We're stationary relative to Jim. And we've also got, so there's a little box there you can see, that's Jim's head camera. So Jim is seeing, of course, the clock in exactly the way that we pictured it when it was stationary relative to us. The light beam is bouncing up and down between the mirrors. But if you look, and we've got a sort of little video effect on there so you can see the trail, you can see that the beam of light that we see is tracing out a triangular pattern across the stage. Beautiful. Thank you.
Can I get off now?
You
Feeling a bit
can,
sick.
yes. Thank you, Jim.
That was a bit fast.
Thank you. What a great use of that wonderful intellect. But it was beautifully demonstrated. What we saw there was, if I sketch it out again from our perspective now, from the audience's perspective, is that here are all those mirrors. So this is the light clock that Jim was carrying. But you saw that from your perspective, watching Jim move, the light took a kind of triangular path as it bounced across the stage between the mirrors. Here is what Einstein's postulate, if you like, Einstein's suggestion that the speed of light is constant for all observers, implies. See, this path is obviously longer than this path. So, if we all agree on the speed of light, then it is obvious that it must take the light longer to tick for the moving clock than it does for the stationary clock. Moving clocks run slowly. This is true. Time really did pass at a different rate for Jim. It passed at a different rate for him than it did for you in the audience watching Jim move. There's no sleight of hand here. Jim really is a time traveller. Our time is personal to us. This is what Einstein had discovered. There's no such thing as absolute time. Now, why don't we notice this in everyday life? Is because the amount by which time slowed down for Jim was minuscule, because the speed he was travelling was so small compared to the speed of light. But if we'd have sent Jim off in a rocket, would you like that? A rocket, just flying out into space. Let's say that we catapulted Jim off at 99.94% the speed of light for 5 years, according to his watch. Then we tell Jim to turn around and come back. It takes another 5 years to get back to the Earth. So for him, the journey would take 10 years. But for us, with our watches ticking faster than Jim's, 29 years would have passed. Jim would return in 2042, having aged only 10 years. It's a real effect. He'd be a time traveller. Time travel into the future is possible.
Okay, so time travel is possible. Did everyone understand that?
Yes.
It's so crazy to get your mind
you're
around
much-
because you think it must be the same amount of time, but it's really not.
Right.
It's like my mind is just like.
Mine too.
All right. So, yes, we can time travel and we can do it here on Earth.
Well, we can time travel into the future, just not the past.
That's correct. You can only time travel to the future. That's right.
Sorry to burst your bubble to whoever was thinking.
So, can the Avengers be real then?
No.
No.
I am probably the only one in this Zoom that hopes.
Doubt that.
I heard a theory where that there was multiple universes, basically.
I mean, yeah, I
Although-
Well,
where
Although
inside
Star
a
Wars is
black
in a different
hole is its
galaxy.
own universe, and there are black holes inside that universe. So there's pretty much just universes inside black holes, and we can't see them.
Like Horton, here's you.
Yeah. So like that's the theory.
Yeah.
So it's just infinite universes and I guess infinite possibilities.
That's right.
And I believe it was Neil deGrasse.
DeGrasse.
Yeah, deGrasse.
Touch DeGrasse.
Oh,
Touch the black hole.
oh, I will never touch the grass.
No, Ashwin, you can't time travel to get Bitcoin.
Oh.
It's not going to be worth much in the future anyway.
Actually, it's probably going to be worth more.
I mean, yeah, like some guy dropped. It was I forgot how much Bitcoin it was. Wasn't that much back then. It's worth $350 million now on a USB stick.
All right, so let's travel. Let's time travel. 28,400 light years to the center of our galaxy, okay? And our telescopes, this is what we saw. So I want you to look at this video and tell me if you see anything interesting or what our astronomers saw.
I see something.
Moving neutrons and protons.
So these are actual stars. So they're so far away, like dots.
Okay, can I say the answer?
Yeah, sure.
It's the pattern of moving stars compared. So they watched the so there's like a black hole and people looked at the stars and so they thought it was a black hole because it was orbiting a certain way, I think.
Excellent. Yes. Do you see those massive stars that are just whipping around something, right? But that something is not there. There's nothing there for it to be whipping around gravitationally. So this is the center of our Milky Way. And because of this, they said there must be a black hole here because there's nothing else around to make the stars do this. So we need a picture of it. So how do we get a picture of a black hole that far away with a telescope?
Robots in a spaceship.
A
An
big
Event
one.
Horizon Telescope.
Yes, but what is that?
It's a good telescope.
Are you referencing
We take a picture of it. That's how we do it.
So you would need, in order to take a picture of a black hole that far away, you would need a telescope the size of Earth.
My gosh.
Where's
Like
the
a
human
Death Star.
population gonna go?
Yeah.
Star 2.0.
Miss
I'm
Kayla.
sorry.
How can we artificially make a telescope the size of Earth?
Just put a lot of
Well,
lenses.
Put a lot of mirrors around. I believe it
That's
was
what
put
I
a lot
said.
of mirrors around the sun.
Ooh, okay.
we
Or it was a black hole.
we could use all the telescopes on one side of the Earth
Put
shown.
it on different planets.
How do you
Right.
get the sun without becoming a s'more?
So all of these dots that you see here for the Event Horizon Telescope are telescopes here on Earth. And what we would have to do is take the light from the event horizon of the black hole, and each single photon, each one of those photons would have to hit every single one of our telescopes at the same time.
Wow.
And we did it. Okay, so each one of our telescopes need to capture that one photon. Does everyone understand that?
Yeah.
That's really difficult. Would everyone
Kayla?
agree? That's very, very difficult. Yes.
I forgot what I was going to say before, but do white holes exist?
Yes.
White
They were-
holes. Do purple holes exist? Do pink holes exist? Do red holes
orange
exist?
White holes
he's
repel
asking
instead of
Miles.
attract.
No,
Yeah. Okay.
Miles
So
asking a serious question.
yeah, so white holes do exist. Well, I shouldn't say do exist. It's a theory of
Could exist.
That's right. The opposite. Basically, it's what the end on the other side of black holes, right? So it would then be you'd be spit out of the black hole into a white hole, into a parallel universe type thing, I think.
I want to go on a white. I want to go into a black hole and come out of a white hole into a go new universe. That sounds cool.
All right, so we want to see first. We got to see if they exist. We got to see.
Lost at space.
We got to take a
That's
picture.
a show.
If you went through a black hole, you'd be
So we
Really
need to take a picture of a black hole, and in order to do this, we need a really big telescope. All
Or
right.
a really big canvas.
So Sagittarius A that's going to be what's at the center of our universe. I want to show you. Oh, hold on. Oh no. Let's see if it'll play. Come on, mister. Here we go. All right.
Hidden by clouds of dust and interference
I'm
from
being
our
a
own
happy man.
atmosphere, black holes have traditionally been very difficult to see from Earth. But recently, 300 scientists working together across 20 countries as part of the Event Horizon Telescope began to probe some prime suspects in our cosmic neighborhood.
You need a telescope the size of the Earth in order to see a black hole. And the technique is actually well known. It's called very long baseline interferometry.
So it's not a single telescope, it's actually a network of radio antennas. We use telescopes on top of mountains, very tall mountains, to get past the Earth's atmosphere. And we recorded a wavelength of about 1 millimeter. So this is pretty much the highest radio wavelengths that reliably can be observed from the surface of the Earth.
The signals arrive onto the telescopes, we time tag them, we record them onto hard disks, and then we ship these hard disks to correlation centers, which are supercomputers that then combine the data together, realign all the signals between the telescopes, and create this virtual telescope the size of the Earth.
You might remember seeing this
Okay,
image
so
back
that's
in
the
2019.
image they got. So what is, now you heard that guy say they used interferometry. What is that? Does anybody know what it is?
Sounds like a type of
Wavelengths.
Is it the is it geometry, but it's infrared?
Sounds like interfere.
Okay, so basically it's a technique that uses the interference of superimposed waves to get information. And superimpose just means like one on top of the other. So a good example is this: who has noise canceling headphones on?
I have
Nope.
headphones. I'm not
Gavin's
sure
got
they're
'em.
Okay, so Gavin's got them. I know Ashwin should have seen
Agreed.
his on. So how does that work? How does it cancel the noise on the outside?
Magic.
Not
Just like
magic.
Bitcoin.
Insulation.
Science.
I know.
All right, so what it's doing is the unwanted noise comes in and there's a recorder that's recording that noise. And this processor records the noise and flips the wave 180 degrees and then makes that sound. So it makes the opposite sound of the noise coming in, which means it cancels it completely out. And then you just hear your music or the audio coming in. Okay, that's called destructive interference. And this is very similar to what we're about to do, to listen in a way to a black hole. Okay, so we have one wave coming in. We're going to flip it 180 degrees, cancel that out, and see what is left over. Okay.
When we hear nothing because all the sound is being sucked in.
Yes, except for if there's a massive event going on in space, like a black hole being formed, like two black holes coming and colliding together, like two galaxies colliding and coming together.
Actually,
So-
two galaxies will collide in the future. Our galaxy and the closest galaxy, Andromeda.
That's right. Yeah. So essentially, this is called LIGO, which uses laser interferometer, okay, for gravitation, to observe gravitational waves. All right. So it uses two laser beams at a certain wavelength, and they come together at a beam splitter, and they cancel each other out. Now, if there's a tiniest bit, and I mean 1,000th of a proton, small change in one of the waves, we'll be able to detect it and tell you if there's some sort of gravitational wave disturbance billions and billions of light years away. So we have two of these on Earth right now. Now, what's better and here, oh, well, here's some of the galaxies coming together. So we actually see these disturbances, then we can look through telescopes and actually pinpoint where this is happening. So here's some galaxies actually colliding together. Here is in Centaurus A, so you can actually see this in the sky. Now, there's a black hole here, but with different wavelengths, we were able to detect those jets that come out of the black hole. So the electrons that are spewing out, the radiation coming out. And to give you a sense of size, each one is 80,000 light years across. So that's how big this thing is, right? And we have future, we're putting interferometers in space, right? So we're using laser technology in space. And when we go to the moon, we'll have an interferometer on the moon to measure gravitational waves of distant objects.
Wow.
All right.
That's Lisa.
So, yeah, that's called Lisa. All right, we have reached our hour mark. Are you guys ready for your Kahoot?
Kahoot! Wait. I need to get Kahoot going on my computer.
Yes, that's fine.
I'm going to rely on my stupid luck because I have insane luck. So I'm on
Stupid
Again.
luck. That's
yeah.
that's what we love.
If you told me to pull
I
a
should
trick
get
shot, I would
them.
fail it, and then when I don't even try, I'd somehow do it by accident.
That's kind of
What's the game pin?
All right, hold on. I'm gonna load it up real quick and then I'm gonna share my screen.
Okay.
It's last time it took a little while to load for a second.
Well, I need help with this. I'm not good with Zoom or Kahoot or any stuff like that.
Okay.
What's the game pin?
How many pages of notes did
loading.
y'all write down? How many pages of notes did y'all write down? I just want to know.
0. I don't
I wrote 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pages. About 10 pages of notes.
Well, how are you gonna read that all while trying to answer a Kahoot?
What's the game pin?
All right, it should be on the screen. Y'all see it?
Yes.
All right, it's 8512181.
Yeah, I need help real quick, so yeah.
That's fine. We'll wait for a second. So all you have to do is go to your browser and put the www.kahoot.it. It should be right here on the screen.
Or you can scan the QR code.
Oh, that's true.
Oh, this is Joe Mom.
All right, so 2 left.
Matt Pack.
All right, I think we're missing 1, or is that Michael? Are you still on?
No, Dad left.
Cool. So that might be everyone. Is that everyone that joined Kahoot?
Ariana is
851.
Okay, cool.
Alright, well.
Oh, all right.
Kim Kardashian!
Okay, everyone looks like we have a VIP who snuck into our
Discharge it.
a VIP snuck into this game.
Yeah, Ariana.
Here we go.
I'm recording.
Oh. We got Graydon first.
Who got it wrong?
I did.
Why?
Oh, good job, guys.
Yeah.
Oh no.
Devon.com.
I'm in 9th place for getting one question wrong.
Good job, guys.
Why, thank you.
Everybody knew that.
I'm Kardashian.
I
All
wonder
right.
when Matt Pat will show
It's
up on
harder.
this leaderboard. I need to make a theory about this. Hold on.
Whoopsillion.
One earth science. You know, I'm gonna
Pick the most reasonable number. And maybe that'll be right.
Ah, there you go. Some people
Who
remembered.
put warp zillion?
warp zillion.
Aliens a purple wall.
So true.
Pick the most scientific answer.
Hey guys, I remember you from co-op.
It's red. It has to be red. It's red.
Ooh, I didn't cover this. Or maybe I did. This was on one of the slides. I remember.
Cost of 1,000. Oh no, I chose wrong. Oh wait, no, it's actually correct. Huh. Yes.
No.
That is the 4 million.
Uh-oh.
No, I thought it was a
Miss Tara, did you
Pretty sure I
create
picked
this?
green. I'm not sure.
Yeah, I created it.
It's cool. You add a lot of questions.
I tried. I think I did less than last time.
That's right.
Yay.
Boom, boom.
Is that you, Ashwin?
No.
Oh, must be.
A moon made of cheese. A moon made of cheese.
The moon made cheese.
Killer in Among Us.
It is both. It is both blue and red.
Good job, guys. I was gonna have to worry if anybody missed that.
Frisbee disc.
A disc. A disc is a disc.
I'm building my son a playground.
TV.
I'm building my son a playground. It looks so interesting. He's climbing all over the playground.
God, I'm gonna lose this. My luck is.
Ashwin.
He's yellow.
Yes.
Second place.
Nina,
space forever.
Graydon.
Observatory.
Oh,
Graydon.
Crumble cookie. Oh, I want to be that person really bad. Haha, I wrote this one down. Twice.
I wrote this down as well. I'm pretty sure that's
See,
I have no
Emma,
idea.
this is
Yeah,
your fault for
but-
being the only
got
ones
it
writing
right.
something.
Stupid. I don't know that.
Yes.
Emma, are you
Yes.
crumble cookie?
Yes.
Oh, I love it. I should have been crumble cookie. Half the length of a foot.
The Schwarzen child radius.
We're only on question 12 of 28.
Who guessed that?
What are we listening? Live on your own juicy
Like
gas.
The ads.
C
Somebody
equals
MC
Oh,
squared.
Oh no, I didn't know.
This is actually red.
I meant
yes,
the speed of
that is
light.
what it is. I'm not trying to throw anyone off. Only to you.
I isolated speed of gravity.
Who
I meant
actually
speed of
guessed
light.
it's red?
I think I got 9 correct in a row.
Emma, yay.
Who's
Crumble
so?
cookies. All matter is both A. Good and evil. Peanut butter and jelly.
Waving particle.
Peanut butter and jelly. Okay, Emma, next time I want you to name yourself
Right in
peanut
a
butter
row.
and I'm gonna be jelly.
Peanut butter and jelly.
yes. No one can take my place. I am superior.
Don't say that.
Starts
I don't even have time.
Einstein's brainwave is obviously.
know all of this.
Because we dug him up from the dead and then we provided him, I guess.
Disappointment. I thought you were taking notes.
I did take notes. I don't even have to read them though.
Hey.
Wait.
Wait. I'm on my 11th streak.
I need Feria to get their streak wrong.
Good notes.
A large baseball glove.
Gravitational wave destroyed.
Good job, guys.
No.
Chemical element is on it. I can get that. I almost clicked that actually.
What
is light?
is light?
What is light? The thing that comes from my beauty.
The opposite of heavy.
The opposite of heavy, man.
Opposite of heavy.
Opposite of heavy.
Fire from the sun. Anybody else's music getting faster?
Oh, a new challenger approaches.
Who's Feria?
The pile.
No, it's your brain on Fortnite, guys.
Your brain on Fortnite.
Man, get this right, guys.
The pile of clothes in your closet.
Oh,
Oh.
Why can't I pass up?
Ooh.
Oh, come on.
Ooh.
Who is Feria?
Who's
Freya, who's
Matilda?
Freya?
a
Oh,
star
that's me,
died.
thank you. I'm
Who's
smart.
Matilda?
I'm Matilda Smart, thank you.
How come I can't pass you?
The star dies when mom makes it do one.
When mom makes it
No, mom makes us take a shower, obviously.
Mothers have
What
all
do you mean?
power, so it should be.
Oh my god. I'm gonna lose it.
Sure,
I
big
didn't.
mom.
Big
Yes,
bomb,
sir.
sure.
I'm gonna do it.
Bit
Sir.
This is actually
Sir.
bird.
I don't remember this, but I think
I
it's
don't-
sir.
If anybody picks red,
Oh, by the way, I believe
Red is correct. I'm
actually
gonna
had a
freak
chance to
out.
cause a black hole
That's what I thought.
Okay, good. Nobody picked red.
No, let's see.
Not even on the leaderboard. Ooh, it's Arch Nemesis.
Oh no, I think it was an electron. No.
All right, everyone. Now we know it's not an electron.
One.
Yes.
Yes.
Good
Yeah.
job.
I knew it.
Oh, I'm 1 point behind third place.
That's right. That's right.
Yeah,
That's
pass
right.
up
That's
Matilda.
right. I'm
Maria,
smarter.
I'm coming.
I'm
Yeah,
better.
I know.
I am better.
I'm in a
That's too bad.
Remember?
Blue is Feria. Feria.
We are calling Feria to the front stage. Your name is Feria.
It is
Shout,
monkey.
scream.
Oh,
I would like
behind
an
Matilda
autograph from Kim
again.
Kardashian. I'm kidding. An elementary part. Darth Vader. Strange.
How is it really easy?
I am.
There you go.
I am.
You had me
I-
there for a second.
I don't even
You had
know.
me there for a second.
I
thought it was
genuinely
supposed to
don't
be-
even
I thought
know.
it was
This
supposed to be like a science quiz.
5. 5.
I did not
Eating too
cover
much.
this. This is something I did
Well, then
not
why
cover.
is it yours?
Oh, that's
Miss Tara, if you didn't cover it, then why is it in the quiz you made?
It's
Oh, I was just seeing who knew.
Oh, of course you were.
You're genuinely making.
If
us
I lose
guess.
my
How
first
dare you.
place, I'm gonna. Okay.
Crumbled
Good.
cookie. Oh, it's crumbled cookie. I thought it was crumbled
I
cookie.
thought
How
it was
much
black.
like
The ultimate heights. Yeah.
Classroom perfection. Yay!
Yes,
I'm
classroom
classroom perfection.
perfection indeed.
Perfection.
Kim Kardashian got it wrong. Wow.
Oh,
How embarrassing.
how embarrassing! Now she has to say it to the public.
Black
They don't
holes
last forever.
don't last
They
forever.
last.
I mean, it takes trillions
They
of
last
years for
Don't
them to
actually
go
last
away.
forever.
But they don't last
I
forever.
don't think they last.
I want to
forever.
become spaghetti. Then I can eat spaghetti.
No, you don't want to become spaghettified.
Yeah.
Let's
I
go
watched-
make spaghetti together, Emma.
I've
Let's
watched
go
this video
and
on
Kim
YouTube.
Kardashian got it
spaghetti.
wrong.
I watched a video on YouTube called
You,
Time Lapse of the
if you enter a
Future.
black hole, you do not
Elon Musk. Ask Elon Musk.
Elon Musk.
ask Elon Musk.
He sent a gosh dang car into space. He knows
971.
everything.
Everything.
Kardashian got it right.
Oh,
Crumbled
wow.
cookie.
That is right. That is right. I am first place.
Oh, this is a tough one.
Last
Oh,
question.
goodbye.
The hard goodbye.
Did you write this down?
I wrote it down. Well, actually, I didn't write it down, but I still know.
Yeah.
Good job.
Yes.
7.
I'm impressed.
I got future. I don't know what role.
Graded
I almost
in.
said what role I am.
Great.
Oh.
Great
Yeah,
job.
man. In.
Crumbled. No, watch it. Watch it be the lowest person. Watch it be Kim Kardashian. Okay.
Good job, guys.
Yes.
There
you go. I won.
By the way, I was place 6. I was
I
so.
got 1,000. I got 17,887
Black holes
points.
for kids, and I still win first place.
Ha ha ha.
Good job, guys. Excellent.
I'm gonna
What now?
spam Oshwin in his Discord that I won.
No, no. Please do not spam me.
All right.
Please.
Spam him.
You guys did great today talking about
Oh my
black
God, bro!
holes.
It's already happening.
All right, I'm turning off our recording, okay?
Okay.
Wait,
Miss
Miss
Taylor?
Taylor?
Oh my God, it's
Taylor?
happening! It's happening.